So today I will be showing you how to record your own dataset using dora-dataset-record-node. Okay, so first you are going to want to build the node itself. After you have built the node, you have to specify some parameters in the config file. First one is the repo ID. So this will be like your Hugging Face username and the name of the dataset that you want to create. Now in single task, you define a task. You define the task that you want to do. In the camera names, you specify based on your camera setup the number of cameras and the names. Like for example, laptop, the front camera, and the top camera, which will be capturing the top view. And you need to specify camera resolution for each camera separately. Now in robot joint, either you can like specify the conventional names, or you can keep it as joint 1, joint 2, joint 3, like that. Uh, so FPS will be the FPS at which the frames will be captured. Then in total number of episode, you specify how many episodes you want to shoot. Now the episode duration is like uh, uh, duration of episode. Reset duration is the period when you reset the environment. If use videos is set to true, which by default it will encode all the frames into a MP4 video. If you keep it as false, then it will like save individual PNGs instead of MP4. Publish to hub will publish it to Hugging Face Hub, and private will make it private. So by default, Hugging Face stores it in this path. So it will be cache, Hugging Face, Lerobot, and your Hugging Face user. Like this. Okay. So if you want to store it somewhere else, you are going to have to specify the path to that location. So I will be demonstrating how to record a dataset on So101 ARM. So let's get it. So in my setup, I have two cameras. One is of laptop, which has the index 0. Like generally, your laptop will have an index of 0, which is your integrated camera. I have set it to 480p. And similarly, I have a front camera which is mounted on the arm. Uh, okay, and I'm using dora-rs port to like control the robot. So in here you also are going to like find which ports the robots are connected. So I have a pair. One is a leader and one is the follower. So follower has this port and leader has this port. So make sure you uh, define it based on your setup. Now coming to the dataset record node. So in the inputs, if you have, let's say, your setup has a top camera, so you define it like top cam image, and let's just add that. Like so. This will be top cam, and let's say that has a path of 2. So this is going to add this as a source. Here I will specify my Hugging Face ID, and let's keep it at demo dataset. Okay, and let's keep. I'm going to pick up battery. Basically, so for example, instead of So101, you have some other arm. So you can like name the robot. I have defined like the FPS is 30. Let's reduce the total number of episodes to, let's say, 3. Let's keep each episode duration like 20 seconds. Reset phase is like 3 seconds are fine because there's not much thing to reset. So based on the complexity of your environment, like for me, it is just putting the batteries back. So it depends on your environment. So camera names, we have laptop front and added a top camera. So to add that, you have to specify the resolution. I have kept this like the default one, the default naming convention for my arm. Okay. Uh, use videos is true, this is false. If you want to add some other top tags like demo or let's say you can add them. And yeah, so rerun will be used as a visualization window. Yeah, let's remove since I don't have a top. Let's get rid of it. Yeah, so start recording. Okay, so as you can see, I can like delete off the robot, but we have an issue with like the front image not being captured. So it is going to be an issue with the capture box. So let's fix it. Let's try 2 instead of. Yeah. So now that is fixed. And I guess we have an error about uh, this file already existing because the dataset was partially created. So let's delete this. So as you can see, it has started. We'll complete the task. Now you can see the message of the episode being saved with this many frames. Now it is like encoding the raw PNGs into an MP4. After that, it will send a message about the reset phase being started. Reset the environment like so. Now we can see like the episode 2 has started. And you can also use this time to use the environment and the videos are being encoded. So ideally, like for small videos, it shouldn't take long. But as like the duration of each episode gets larger, it may take some amount of time depending on your system. This is the last episode. It is saving the last episode, as you can see. Yeah. Now it says all 3 episodes completed. Let's go ahead and close this. It is here. You can see the metadata. It has this many frames, the number of episodes, this frame rate, and all the information. So now that we have recorded our data set, now it's time to train a model. We are going to train a ACT model. So this is how we're going to do it. I have it ready here. So my laptop doesn't have that much of VRAM, so I'm going to reduce the batch size to 4 so that the model fits in my laptop. So we are going to copy paste this one. And it will start training. You will see this will spike up just a moment, and it will start training. By default, it will train for like 1 lakh steps and save every 20,000 steps. If you want to change that, you can add arguments for the save frequency so that it saves more often. So yeah, you can see CPU is full. It has started training. So once you have trained your model, then you are going to run the inference using dora-policy-inference node. So this is also similar. You have to set up some things like the mappings for your cameras, uh, obviously your robot sport, the task, and the path to the model. So, yeah, let's do that. This is also in the example file. So we had top cam, the front cam, the second one. We just check the boards. So leader 0. So we do this. Then you have still the part to your weights. In my case, it is old and weight. Uh, this print it. This here. The box. So yeah, this will for running the inference you just simply so, so this is should run